Konbanwa.
Konbanwa.
来てくれてありがとう。今日はカフカにして学びます。Okay? はい。私はニキルです。私は Eclipse Collections のプロジェクトリーダーです。はい。カフカとは何ですか？ Okay? カフカはトランザクションログです。Okay? ごめんなさい。日本語ので話せるのはこれだけなど。背後に切り替えます。Okay? ごめんなさい。yeah. Okay. So, I'm Nikhil Nanivadekar, like I said before in Japanese. I'm the project lead of Eclipse Collections, and quickly we are going to look at what Kafka is today, and we are going to look at how we will end up having a quick reference implementation and discuss how Kafka actually works. Okay, so the very first thing is, like I mentioned, Kafka is a transaction log. Okay, and when I say a transaction log, it is exactly same as a database transaction log. Okay, now why is it similar to the database transaction log? The reason for that is the source of truth is always in a transaction log. Are you able to see this, or do you want me to make it bigger? Make it bigger? Okay.
Little bigger.
Yes, okay. Good?
Yeah. Okay.
Perfect? Okay. All right. So the source of truth, because I saw everybody like trying to figure out what I'm writing. So the source of truth is always in the transaction log. Okay, exactly same as the database. In a database, in case you lose out anything, what do? You just play the transaction log and you come to that state. Correct? In Kafka, all your data or all your records are stored as a transaction log. And what Kafka does is it ends up storing all that data in terms of log files, okay? In terms of log files on your actual machine, okay? So if it is a cloud implementation, then on the file system of your particular node, you will have the transaction logs. If it is on an actual machine, then like it is on my laptop right now, you will see that the logs are created. Okay. Then what does Kafka let you do? It lets you decouple producer and consumer. Okay. And consumer. And when I say decouple producer and consumer, what it essentially means is your producer can go on producing data, messages, records, and your consumer can go on consuming messages and records, and each of them can do that at their own rate. Okay, let's say a producer produces data at 1000 messages per minute, but the consumer only consumes the data at 1000 messages per hour, right? The producer does not have to wait. The consumer can go on doing its job, and it will end up being true to the order. Okay, now going to the next one. Since Kafka is a transaction log, Kafka will retain order, okay, in which the messages were produced. Okay, so this is another one of the important things. And lastly, or second to lastly, Kafka allows, because of the decoupling of the producer and consumer, there can be single producer and multiple consumers. Okay, and this is especially necessary when if you go to old implementations where if it is a file-based transfer. Okay, So what ends up happening is a producer will create a file, keep it on a node, okay, and then each consumer will come and consume that file, okay. Until the last consumer has finished reading that file, the producer cannot go publish a new file, right? And that creates slowness, that creates coupling between producer and consumer. But here, if by decoupling, Kafka lets each of its consumers consume the data in their own rate. Okay. Now, in order to understand Kafka, I'm going to explain it using an everyday example. Okay, of trains. I love trains in Japan. I'm from India originally. The train system in India can take a little bit of inspiration from Japan. Okay. So, but I love the trains in Japan because they're efficient, they work on time, and I mean, they just work, right? So, if you were to look at this entire Kafka based system, it is similar to your train system, okay? Why? Okay, now in Kafka, you have one producer, you can have multiple consumers, okay. You can also have multiple producers and multiple consumers, okay. But all of this is all of this is synchronized or orchestrated by something called as Zookeeper, okay. Let me quickly delete this and type it out. Okay, so the first component of Kafka is Zookeeper, okay. In this case, it's your station, okay, your railway station, where all the trains come at the same time. And it is the station's or the station master's job to do the coordination. When does one train, on which track, which platform the train comes, right? So Zookeeper does the exact same thing like what a railway station does, okay. Basically, it coordinates the multiple Kafka brokers. It stores the configuration, okay. It stores the topic. Uh, it stores the configuration for topic, producer, and consumers, okay. So as you can see, it's like a train station. It is keeping all the necessary metadata for your system to process, right? Now the next one is a Kafka broker or a server, okay. So broker or server. If anytime you hear anyone saying a Kafka broker, what that essentially means is it's a Kafka server, okay. It's nothing different than your actual server running, okay. Now your server in this case, okay, again it's something which actually hosts your Kafka topics and retains your messages. So here uh, it stores the the messages and retains them, okay. Then the next one is the a topic. Oh, okay, a Kafka topic. So topic. Now going back to our railway analogy, okay, topic is like your train lines, right? So let's let's look at any city where you will have multiple train lines going in different directions, correct? So there is a logical separation, right? It won't happen that suddenly the train which is supposed to go to Tokyo is on the same line as the train which is supposed to go to Kyoto, because they are on the opposite sides, right? There is a logical separation that is done, right? So a topic is nothing but a logical separation of messages, okay. And whenever a producer is producing a message, they end up publishing or pushing it to a topic, okay. That means, now going back to our railway analogy, if your line, okay, if your train line is a topic, then your producer, right, becomes your train, correct? Because the producer is actually publishing the messages, correct, on that particular line. So now producer, it's easy, it produces or publishes messages to the topic, okay. And then lastly, it's the consumer. Consumer is like all the train passengers who actually go to the topic, go to the train line, get on the train, and go to their destination. So they basically consume the messages from the topic. Okay, so it is, I'm trying to explain it using a real world example so that you can relate to it, how all of these components fall into fall into place. Okay, consumes messages. All right, so again, going back, the most important component, or rather all of these are important, but the single point of failure is Zookeeper. Okay, because you have an Apache Zookeeper instance. That one Zookeeper instance is supposed to do all the coordination. Zookeeper is known to do that. That is its job. So that is your one single point of failure. You have a Kafka broker and server, or Kafka broker slash server. Basically, they are that's the server on which the actual messages are stored. Then you have a topic, which is a logical separation to which a producer will publish the messages, and then you have a consumer which consumes the messages from the topic. Okay, so far so good. Theory understood. Now let us actually look at it in code. Okay, I will end up explaining all of these components again by bringing them up one by one on my laptop. Okay, and everything is config driven in Kafka. So whatever I'm doing right now on my laptop, you'll pretty much similarly do it on your on your cloud machine, or on your server, or on your dynamic compute cluster. Okay, so let's first go here and let us start Zookeeper. Now when Zookeeper will start, it will end up binding itself to a particular port and an IP address. Okay, once it takes like a minute or two to start when I'm not connected to Wi-Fi, but when it starts, and then what you do is you take that port and server, okay, and you use your Kafka broker when it comes up to connect to that Zookeeper instance. So now if I'm to pick up my broker, and before I do that, let me actually list the config server properties. So here, because yesterday someone asked like how does everything get connected. So if you see here, the listeners are at 9090. That's where my Zookeeper is running. Okay, and I give an ID of 0 to my broker. Okay, so that's pretty much what is happening. So that's my server ID. You can have more than one server running. So in an ideal Kafka system, you will have three, or more than three, like a cluster of servers running. Because what Kafka allows you to do is it allows you to have a highly available and a fail-safe system by the virtue of redundancy. Okay, so if you have a cluster of multiple Kafka brokers, like you have, like let's say 3 for example, then amongst 3, Zookeeper will elect one as a leader, which always synchronizes the data across all the clusters. Okay, and then what Kafka guarantees is, in case you have n replications, so when you have 3 clusters, you'll have 3 replications. If you lose one cluster, if you lose one broker, it will still allow the system to function. Okay, so that's how it achieves fault tolerance. Okay, but right now it's for the sake of demo. We'll only do with one server. Oh, sorry. Okay, now when the server comes up, you will see that it actually binds to the same Zookeeper instance, and then now you have a Zookeeper and a server up. Okay, if I were to bring up more servers, then Zookeeper will decide who is the leader. The responsibility of the leader is that whenever whenever a producer publishes the message, it first goes on the leader, and then the leader synchronizes it across all the replicas. Okay, but you can see the server has started and it has connected to the same Apache Zookeeper instance. Now after that, after the broker, our next what do you say, our next component was the topic. So we need to create that line, like the logical separation, the topic to which a producer can publish the messages. So if you see here, again, it's a shell script where you're saying my Zookeeper is running on localhost 2181. That's my port 2181. Okay. Previously in the config, when I showed localhost 9090, that 9090 is the port at which my server is going to run. Okay, so two different things. But what I'm doing is whenever I'm creating a topic, I delegate it to Zookeeper to figure out which broker it should create the topic on. Okay, so going back to a railway analogy, you delegate it to the station to figure out where to lay the platform. It's exactly the same thing. And here we are saying there's going to be a replication factor of 1. Replication factor is what I was discussing about when it's fault tolerant by the virtue of redundancy, because what ends up happening is if you have a replication factor of 3, then Kafka will require you to have 3 servers where it can replicate the data. Partition is one here. Partition is a concept which is used for parallelism, because imagine this. Now again, going back to our train example, right? Now there are so many passengers which get on the train. Now imagine this: if the train had only one car, only one bogie, right? What will happen? Right? All that it had one bogie and one door or two doors, let's say. Everyone would want to go only through that one door, right? So it will be complete chaos. So what they did was, in a train, they ended up adding multiple bogies, right? Multiple cars, and the cars have multiple doors, right? So the passengers can get on and get off in parallel, correct? The partition is the exact same concept. A producer can publish a message to a particular partition, and a consumer can consume the message from that particular partition. Okay. Now, what Kafka guarantees is the ordering within a partition is maintained. Okay. So if one producer is publishing, let's say, 100,000 messages across 10 partitions, okay, then in that case 100,000 divided by 10, okay, that is 10,000 messages per partition will be present, and now you can have 10 consumers consuming messages across 10 partitions, one per partition. So the producer has produced 100,000 messages, and then you can have one consumer, oh sorry, and then you can have one consumer actually consume messages in parallel. Okay, so let me create the topic quickly, and then so once I create the topic, and the name of the topic is test, if you see that, hyphen topic space test, that's the syntax. And once the topic is created, Kafka will give me a message saying topic successfully created topic test. And now we are ready to actually produce and consume messages. So what I'm going to do is I'm going to have two screens, the two shell scripts, two bash windows, sorry. On the left is my producer, on the right is my consumer. Okay, does that make sense? That side is the producer, this side is the consumer. Okay, so let me quickly bring up the producer and then show what I mean by decoupling of producer and consumer. Okay, so I'm bringing up the producer there on that side, the father side. Okay, uh, and again you will see it shows localhost 9090. The localhost 9090 is that's where my Kafka server is running. Okay, here I'm not looking at what Zookeeper is doing, because I'm my producer. As a producer, I'll say get the broker list, pick up 9090 and start installing on it. Okay, I'll start running on it. Now I will say message 1, okay, message 2, message 3, right? So I've published 3 messages, okay, but there are no consumers, correct? So nothing has happened, like you don't know whether the message has gone or not, but you can be rest assured it has gone. Otherwise there will be an error coming out here, okay, that the message was not successfully published. So now when I say producers and consumers can be completely decoupled, let me go bring up a consumer to show that. Okay, so now when I bring it up, and you will see basically it's on the topic test here. I want to consume from the topic test, and I want to create a group called as a test group. So a group is called as a consumer group. That's how Kafka allows one producer and multiple consumers by the concept of consumer groups, because you can have multiple consumer groups. Okay, now you'll see it came up and it consumed the 3 messages which are there. Now if I start publishing messages here, you will see that on the other side they will keep on coming up. So it's the producer and consumer, right? Now let's say my consumer goes down, right? In a system, consumer says, okay, I have an issue, I'm going to stop consuming, right? But the producer is going to keep on producing messages, right? 7, message 8, message 9, message 10, okay? But now the consumer says that, oh, yeah, we fixed what the issue was, now it's back up. What Kafka allows you to do is it allows you to configure where it should pick up. Okay, generally you pick up where you left off. So that's what I'm going to do now. And when it comes up, you will see that it will start consuming messages from where it left off. Okay, and that's another beauty of Kafka where you don't have to worry. So it finished at 6, and when it came up here, it just consumed 7, 8, 9, 10. So it started where it left off. Okay, any questions so far? Because I think I've got like another 5 minutes or something. That's where like I would want to show. You have a question? 5 minutes, yeah. Okay, yeah. That's where I'll quickly show how you can have one producer producing to multiple producing to one topic, and you can have multiple consumers consuming the data. Okay, for that I'll switch to Java code because it's faster. Okay, I'm going to keep my this consumer running as is. I'm going to bring down my producer here. No reason at all. Kafka allows multiple producers to produce on the same Kafka topic as well. That's fine, but it's just to reduce the confusion. Okay, so now I have this small Java program written where can everybody see the code? All good? Okay. So Kafka, like I said before, works on properties. It's highly configurable. You can decide what you want to do. So in this case, I'm going to say that my Kafka server is at localhost 9090, exactly what it was before. And my key and value is going to just be strings, okay, when you serialize it. And now when you publish the record, just publish the record to test. Okay, makes sense? And the record is nothing but it's a for loop which goes from 0 to 100 and it says publishing message. Okay, now remember I have not brought down the other consumer. Okay, so I'm just going to turn this on. I'm just going to run this main program, and while the program runs, I'm going to, if you see here, it published those messages and it consumed. Okay, it's instantaneous. Okay, now what I'm going to do is I'm going to start up another consumer. Okay, and then at that time we'll see how the behavior looks like. Okay, now on the consumer side, again everything is configurable. We are saying that hey, go connect to localhost 9090, that's where my Kafka server is, and now create a test group called as test group 1. You remember previously my test group was just test group, right? So I'm decoupling my multiple consumers here. Okay, and reset the offset to earliest and consume it. Okay, so and here when for Kafka consumers you have to subscribe to a particular topic. Okay, producing messages on Kafka is super easy. You just choose which topic you want to produce to, and you just produce it. You can choose partitions, you can do multiple things, but it's super easy. On the consumer side, you have to be a little bit careful what you're doing. Okay, so let's start the consumer, and then let's see what happens. So if you see, the consumer came up and it actually ended up consuming all the messages which were there before. Okay, including the message 1, message 2, message 3. You remember which I had published. Okay, so this consumer, when it came up, it started from where it left off. Right now, if I go back to my producer and I stop my producer and let's say I restart it. Okay, uh, let's see. Let's say I restart it and keep this on this side, right? So you will see it goes on consuming again. Okay, so this allows you to decouple producers and consumers. Okay, and if you if you want, like, are there any questions?
I have a question. What's the footprint on the server to have multiple groups consuming the message if my my consumer goes down
Uh-huh.
and I keep producing message, the Kafka is gonna keep the message for me inside the memory or disk or something.
Yeah. So your resources are limited to your actual file disk space. So Kafka doesn't keep it in memory. Kafka actually writes it. So even for this one, you will see Kafka ends up writing it as logs. Okay. Now what ends up happening is when the producer produces a message, okay, the let's imagine it's only replication factor of 1, so only one copy is kept. Only that one copy of the message is maintained, okay, in the logs. But if you have multiple consumer groups, remember what Zookeeper does. Zookeeper keeps the configuration, okay. So Zookeeper now knows on this particular topic I have, let's say, 5 consumer groups, okay. Now it's Zookeeper's responsibility to keep which consumer group is at what point in consuming the message. And in Kafka terms, it's called as an offset. So Kafka gives a unique ID to every message which is produced. Okay, and as and how you consume it, as a consumer, it's your responsibility to tell Kafka, okay, I've consumed this message, I've consumed this message, and when you do that, it's called as an offset commit in Kafka terminology. When you do the offset commit, Kafka moves. So let me quickly draw it. It's a so so what will end up happening is uh, here, let's say you have consumer 1, okay, the it is at offset number 100, okay. Then you have consumer 2, it is at offset let's say 120, okay, and 3 and so on and so forth. Let's say 3 is at 1, 3 is at, let's say, only 20, okay. Now Kafka, and let's say in total there are 200 messages, okay, total messages are 200, okay. Now what Zookeeper keeps on doing is it says the consumer offset is 100, consumer group 1 offset is 100. When the consumer goes and asks Kafka for the next message, again everything is configurable. If the consumer wants, they can go back to 0 every time, but generally you don't do that. But let's say Kafka, the consumer goes and says, give me the next message or give me next 100 messages. Kafka will go and say, okay, you're at 100, I have 100 more messages, take these. Consumer consumes, says, I have consumed this message. Kafka will go and move this offset to 200. Okay, and that's how Kafka maintains using the offsets. Kafka maintains the decoupling. Any other questions? All right. Thank you very much. Arigato gozaimashita.